With today's lesson, ladies and gentlemen, we are going to be getting into the section that I think is probably one of the most difficult in Chapter 1. And it's one of those sections that you have to trust everything that you have done up to this point. So if you felt pretty comfortable in Lesson 1.1 using addition property of equality, subtraction property of equality, division property of equality, and multiplication division of equality, or basically whatever you do to one side, you got to do to the other. That's step 1. Lesson 2, making sure you're following your rules. Parentheses and fraction bars get taken care of first. Then you combine your like terms. Then you undo addition, subtraction, undo multiplication and division, and then you check your answer. You get into lesson 1.3, variables on both sides. Same rules, except for we have that 1.5 rule. So parentheses and fraction bar, combine like terms, and then isolate a variable to one side of the equation. And then go through your other rules, undoing subtraction and addition, undoing multiplication and division, and then you check your answer. Today, we are going to be doing exactly the same thing, but now you're going to have multiple variables in your equations. When you have multiple variables in your equations, you're going to follow the same rules, but we're not solving for one solution. We're solving for the other variable to find the possible solution for that variable. So the notes that I have on the sideboard are some examples of this. To solve for the variable without finding an answer. So in this case, we're solving for y. The problem is listed out. In this case, we have 6 equals 4x plus 9y. First thing you need to do is isolate the variable. We want to isolate y, so we're going to get rid of all the other variables to the other side of the equation. So we're going to minus 4x to each side. Then we need to isolate the y variable by itself. So in this case, it's 9 times y. So we're going to undo that by dividing by y. When we divide by everything on the other side, which gives us our answer. We will go through more of these problems, especially our first example that's up on the board that you're seeing here. That's what you're going to be seeing. Then our second part of our class today, we're going to be rewriting formulas. And this is what we were doing yesterday in the activity, and a lot of you were getting pretty frustrated. Hopefully after today, you'll start seeing it. It'll be a lot easier for you, okay? The formula that I put up here is probably not a very fair formula to put up here because I use the formula of a cylinder, the volume of a cylinder, and there's cube roots and everything else in there. It's just, I just want you to see the structure of what I was doing here. And based on Kylie's eyes right now, it's a little scary, okay? So what I need you guys to do is once you kind of wrap up with these notes here, go ahead and grab a sticky note, and we're going to work through this first problem right here, okay? So has everyone got a sticky note? So let's go ahead and copy on that sticky note 2y plus 5x equals 6. So in this problem, we're looking to solve for y, get y by itself, okay? Well, if we take a look at this, it's set up very similar to the problems that we've seen already, except for now we have 2 variables on one side of the equation. So like I said before, we want to isolate what we want to solve for. We want to solve for y, get y by itself. So there's no fraction bar here. There are no combining like terms. So what we want to do is isolate y by itself, so we need to get rid of all the other variables to the other side. So in this case, I have a positive 5x. How do I get rid of a positive 5x? Aaron?
Subtract 5x.
So I'm going to do the subtraction property of equality. We're going to subtract 5x from this side. Now, when I subtract it to the other side, 5x is together. It's its own identity when it goes over there. So even though we have 2 numbers on that side, we cannot combine these terms. So it just stays negative 5x. Okay? So when I move it to this side, I'm going to rewrite what I have. I'll have negative 5x. Now, is this a positive or negative 6 here? So we're going to plus 6 equals 2y. So now we're going to do exactly what we did before. We want to isolate and get y by itself. It's 2 times y, Clayton. So what do we have to do?
You have to divide by it, too.
Okay. Now this is what's different. When we divide or multiply this product over here, we do it to everything over here. So we're going to divide every number that we see, even if it has a variable attached to it. We're going to divide it by 2. Okay? So in this case, we have -5 divided by 2. You do not have to actually put that through a calculator or do it in your head and write it as a decimal. I want you to keep this as a fraction. So 5 halves, -5 halves, we just write -5 halves x. So that's taken care of. Now, we also want to divide this by 2 over here. What's 6 divided by 2? Grace? 3. Positive or negative? Positive. There we go. That is our solution for this. We've just solved for y. So y is all by itself. Y now equals -5 halves x plus 3. Ms. Cornelli, do you see anything?
No, I say that looks good. And the reason why it's so important to keep it with the x in the front is because as we move forward in our book, we're going to use y equals mx plus b for a slope-intercept form, and we're going to be graphing that. And if you already practice setting it up like this now, it's going to be so much easier down the road to just keep using that stuff. I know it sounds scary right now, but you'll be fine.
And it is a mathematical rule. You try to keep your variables to the left. Okay? You always want to keep them to the left as you're working through the problem. All right? Any questions on this? All right, so then we're going to try some of these. All right? So our next part that we're going to be covering then is rearranging formulas. Now, this is where yesterday some of you got kind of frustrated. I'm going to walk through this. The formula that we have up here that we're looking at is the surface area of a cone. You don't need to go through and solve for surface area of a cone. We're not getting into solving surface area of a cone. We're not going to be even doing anything with volume or anything like that. We're just taking these formulas and solving for one of the variables or a side length in that equation. So just like we would any time, we're going to start by rewriting the equation. So the surface area of a cone is S equals pi r squared plus pi r L. Okay? We want to isolate and get L by itself. It's probably better if we do it in red. Okay? So we want to get L by itself. Now, the thing that a lot of students are looking at here, they see all these different either symbols or variables, and it kind of gets overwhelming. Now, when we look at this, we have pi times r squared. Think of that as one thing that we're going to move together because they're being multiplied by each other anyways. This would be very similar to saying 2x. If we want to isolate and get 2x to one side of the equation, we can minus 2x from one side as long as we do it to the other. Think of it that same exact way. So we want to get L by itself. Right now we are adding pi r squared plus pi r L. So we want to get rid of this. What will we do? Will we add it or subtract it, multiply or divide it? I saw someone divide. Remember, look at this as one term. This would be like 3. So in this case we would, we're just going to subtract it. So we're going to subtract pi r squared from this side. This cancels. Whatever you do to one side of the equal sign, you must do to the other. So we have now S minus pi r squared equals pi r L. Okay? Now, pi r L is being what? All these are being what to each other? Aaron? Yeah, they're being multiplied. So if we want to get L by itself, what are we going to have to do with the other two? Blake? Yeah, we're going to divide those two. Now, they're exactly like before. This is all one term, okay? It's pi r. It's not pi r squared. It's just pi r. So we're going to divide this from this side. Now, whatever you do to one side, you must do to the other. So we're going to divide pi r from this side. Are any of our terms exactly alike here? Now remember, this term up here is pi r squared. This is just pi r. So we leave it just like that. That is it. We don't have to mess with it. We don't have to change anything. So L now equals S minus pi r squared divided by pi r. We just rewrote this formula for L. All right? Any questions on that?